Okay, so in this video we're going to look at some super basic differential equations because they included in this chapter. But basically, chapter 11 has all to do with differential equations, and we're going to get there eventually. And you can take a full course in college on differential equations, and that's just going to still be an introduction. Differential equations is a very, very, very big topic. So you could spend a lot of time studying differential equations, and so I'm just going to very, very briefly give you a very, very simple lecture on very simple, super basic differential equations. Okay, so what are they? They're equations that contain derivatives. Okay, and so let's just sort of come up with let's just sort of say here we're going to say velocity. I'm just making up an example that's a little bit different from the examples that you see all over the place. I'm just going to say velocity is equal to the square root of time. And we also know that velocity is equal to is the first derivative of position. So I'm going to say v is equal to dx dt. And then I'm also going to say that v is equal to t to the 1/2. So I'm going to say that dx dt is equal to t to the 1/2. Okay. So now I'm going to rewrite this one other way. I'm going to keep. So now I've got this, that the first derivative of position with respect to time is equal to time to the 1/2 power. Now I'm going to write this again. I'm going to write as dx equals t to the 1/2 dt. Anything that I can do to one side of an equation, I can do to both sides of the equation. Anything you do to both sides of an equation yields a new equation. So if I've got x equals 3, my equation. Now if I multiply both sides by 2, I get 2x equals 3. So I x by 2 and I get 2x. Multiply 3 by 2 and I get 6. It's still a valid equation. Now if I square both sides, I get x squared equals 3 squared, or 9. So anything both sides will give me a new equation. So here I multiply both sides by dt. And then what I'm going to do is, the next thing I do to both sides of the equation is I'm going to take the integral. So I'm going to take the integral of dx equals the integral of half t. All I've done is I've just basically added a symbol to both sides of that equation, which means take the, and if I do it to both sides, it's going to be okay. So then I'm going to, on this side, I'm going to get x plus c, and then on this side, I'm going to get t to the 1 plus 1/2 is going to be 3/2. Got to multiply the reciprocal, that's 2/3 plus c. Okay, well now I got these two C's. I'm going to call them C1, 2. But what I'm going to argue is that I can write this as x equals 2/3 t to the 3/2 plus just one C. Why? Well, C1, C2, C are all constant. So I could say, so let's say C1 is equal to 2 and C2 is equal to 5. Well, then I could just say that C equals to 3. Suppose I said C1 is equal to -1, 2 is also equal to -1, then I could say C is equal to 0. C1 is equal to pi, E, then C is just equal to E minus, or yeah. It doesn't matter. This is, I don't know what it is, but I can subtract off this number, which I also don't know what it is, left with a third number that I also don't know what it is. So C stands for some, we just don't know what that constant is. So there's my formula that if, so dx dt is equal to t, so that x is equal to x to the 3/2 plus c. And so I can make a little table and time velocity keep the math simple. 0, 1, 4, 16. Then my velocity, remember my velocity was equal to, so that's going to be 0, 1, 3, 4. But now my addition to be given by this formula, 2/3 x plus 1. So 0 gives me 0, 1, 2 gives me 4. I take the square root of 4, so it's 16/3. And then I have 9, so that's going to be 27, so that's going to be 50. And then I'm going to plug in 16, and I'm going to get 128/3. Okay. That's one possibility. That's one possibility. Another possibility for my position would be 5 7/3, 20, 59/3, and 133/3. That's also a possibility. Because of that plus C. In this case, that C has a meaning. In this case is equal to position. So I'm going to say x final equal to, that should be a t. I'm sorry, I'm an x. 2/3 time to the 3 my initial position. Is something that we just kind of throw around in calculus. It's really, really important. And when you start talking about actual it has a meaning. And so that meaning in this case is the initial positions. The initial position plus that